Hi, my name is Robert Hunting. This is one of several in a series where I discuss important issues in mathematics learning. Do children need to be able to learn and have rapid recall of basic number facts in an age of calculators, laptops, tablets and other smart devices? Is rapid recall of number facts beyond some children? How can children best learn the basic facts? These are some of the questions I will attempt to answer in this video. If there is one mathematics learning aid to be found in many homes, it is the multiplication tables chart, more often than not attached to the back of the toilet door. There is a general expectation in the community that children will master the multiplication tables. Experts distinguish two distinct aspects of the task of learning tables and number facts. The first aspect, known as the integrative phase, is where the meanings of number facts are learned, including connections between related facts. The second aspect, known as the repetitive phase, is where number facts are practiced so as to achieve the goal of automatic response, or instant recall. The first aspect is an important phase in the first 3 years of elementary education. The second aspect gradually assumes priority starting in about the second grade. In the integrative phase, children consolidate numerical knowledge begun long before they start school. For example, many children already know doubles up to 5. 1 plus 1 is equal to 2, 2 plus 2 is equal to 4, 3 plus 3 is equal to 6, and so on. They can tell you 1 more than and 1 less than numbers up to 10, and sometimes beyond. Children in the kindergarten year and first grade are beginning to explore complementary addends equal to 10, such as 1 plus 9, 2 plus 8, 3 plus 7, 4 plus 6, 5 plus 5, and so on. While young children can tell you orally the sums and differences of small numbers, up to 5 or even 10, they are yet to be able to read or comprehend formal mathematical expressions, such as, for example, 3 plus 2 is equal to 5. They need to learn what the symbol 3 means, and what the symbol plus means, and what the symbol equals means, and so on. Teachers will understand that there are technical terms for the plus sign, plus, add, and there are action-related terms in the vernacular, such as 3 joined to 2 is the same number as 5, or 3 put with 2 makes a total of 5. The addition fact 3 plus 2 equals 5 does not exist in isolation. There is a family of related facts. 2 plus 3 is equal to 5. 5 minus 3 equals 2, and 5 minus 2 equals 3. It is important that children understand the interconnectedness of numerical relationships, such as those just detailed. There are extended facts based on the basic number facts. These are vital for performing arithmetical calculations using larger numbers. Just as 3 plus 2 is equal to 5, so 30 plus 20 is equal to 50, and 300 plus 200 is equal to 500, and so on. So in the integrative phase, children learn to associate and coordinate physical, symbolic and verbal representations of numerical signs and symbols. In addition, they learn that numerical relationships are connected in various ways into a web of mathematical knowledge. The consensus of opinion, based on research evidence, is that children will be more effective in achieving rapid recall of number facts if they have first achieved a foundation of meaning to support their memorisation effort. In the repetitive phase, there are more or less efficient ways to achieve rapid recall of basic number facts. So, for example, reciting or chanting multiplication facts in order 3 times each in unison by the class together, orchestrated by the teacher, is not an efficient approach. Why? First, group practice is inefficient because some individuals may already have instant recall of those facts, so they are effectively wasting their time. Second, in real life, the need for instant recall of a number fact is not embedded within a set order. It will occur at random. The recitation of a tables chart will become automated, but within a stimulus response chain where recognition of 6 times 3 equals 18 becomes a trigger for recalling 7 times 3 equals 21, the next fact in the list. I will demonstrate a simple method for practicing number facts that incorporates desirable aspects, namely tailored to individual ability, random delivery, efficient and easy to use. You will need some blank flashcards or playing cards from a craft store and a felt pen. First, decide which set of number facts to practice. It is best to choose a small set to begin with. We will test knowledge of the 8 times multiplication facts. On blank playing cards, record the nominated facts, 1 fact per card. Shuffle the deck. Deal the deck 1 card at a time, fairly rapidly, less than half a second between each card. You ready?
24, 16, 14, 80, 56, 8.
If the person responding hesitates or gives a wrong answer, that card is placed in a separate pile. It is important to practice facts that the person is unsure of, rather than facts they get correct. Practice continues only using the cards with facts that gave trouble. You ready? Let's go.
48, 32.
These cards may be reviewed first. When the person seems to have mastered the troublesome facts, add these cards to the original pack and repeat the first dealing after shuffling cards. Notes can be kept of troublesome facts for each of the multiplication tables. Practice these facts on a regular basis. It is better to do short bursts of practice often, rather than a concentrated session just once. These principles, individual practice, random delivery, and regular short periods of practice with a record kept of progress, can be used to evaluate alternative methods accessible through the internet on your laptop, tablet or smartphone. Why bother with learning number facts with easy access to calculators and electronic devices? Truth is, it is much more efficient to access memory than to reach for a device, switch it on, then key in the required numbers, if you happen to have access in that moment. True, there are some children, a very few, who experience the utmost difficulty committing number facts to memory. Rather than such children being held back in their progress in general mathematical education, allow them to use a calculator or some other aid, such as a tables chart taped to their desk. We know some children are more attuned to visual, holistic processes rather than sequential or logical processes. In that case, teachers might afford them alternative opportunities for accessing number facts using geometric or spatial methods instead of conventional approaches, like the 10 frame. Children who successfully master number facts are likely to make good progress in their further mathematical development. You can learn more about how children learn tables and number facts in Chapter 8 of my book, The How and Why of Teaching Elementary Mathematics, available through the iTunes Store, Amazon or Google Books. Visit my website at www.palm-ed.com or Facebook page at www.facebook.com/hellopalm.